Hi everyone, welcome back to the workshop, and it's repair time again, and this time I've got an Agilent E3633A single rail power supply. Now you shouldn't be any stranger to this power supply because it is actually my own one that I repaired 3 years ago, and I've been using it on and off ever since. However, it's developed a fault. Not surprised really when you look at the original repair video and the original state of this power supply, both the front panel etc and the electronics. I had quite a job getting it up and running, but it's been working great for the past 3 years until last week where it developed a fault. So let me power it up and demonstrate that. So before I actually switch it on, I'm actually going to hook up a multimeter to the output, with no load of course. And let me put power on. And of course on power up, the output is by default off. If I just try turning it on, you can see I immediately get an error there. I've got no output, which is shown in the meter as well. But I can actually wind up the output and it will be correct on the actual output bananas, as you can see. Now the error, there's an error button here. If I press that, it'll show there's an error 718. More about that later. And I can actually erase the error completely. And from that point onwards, the power supply will work perfectly. In fact, I can change over onto 20 volt output. And I can wind the output up and it's perfect. And if I put the power supply under load, it works perfectly as well, and the correct current is recorded on the front panel there. No errors. Now if I try and recall an existing saved configuration, let's go recall. I'll recall number 1. I had it set to 5 volts and it works perfectly. If I try and recall number 2, I think I've got something in there as well. Yeah, 6.9 volts. That's working perfectly as well. So sometimes the error, when you clear it, disappears forever. Sometimes it completely, you're going round in circles. The error will appear, you reset the error and it'll just come back straight away, and you'll get nothing but the beeping all the time and the error flashing up in the display. So I think the first thing I'm going to do is open up the power supply and let's take a look inside. Well, there's the cover off and you can see inside, and it is actually a single board construction. You can see it running from front to back right at the bottom there. These Agilent power supplies come in many different configurations inside, although they all look pretty similar on the front of the panel, but this one is a single board construction. You've got a large transformer here that gives it this high power output, and you've got a large heatsink here and a fan in the front there, and you can see just down there there's a microprocessor down there, and the power supply side of it, you got the large electrolytics up here, the GPI interface down at the bottom there, and a bunch of capacitors down there as well. Nothing looks out of place, nothing looks like it's leaked, there's no capacitor leakage that I can see. So the first thing I'm going to do, I'm not going to actually rip it apart just yet. I'm going to turn the unit round because there is actually a few test points on the rear of the PCB, and I should be able to measure the power supply section. I think there was plus or minus 15, plus 5 volts, that sort of thing, and let's see if that's at all stable. Right, let's power it up. Let's put it in its error mode. You should hear some beeping. Yep, there we go. And straight on, find a nice ground. And you can see you've got some power supplies dotted around. You should have plus or minus 18 or plus or minus 17.4. Here's a minus 17.4. That's reading minus 18. Now I do remember they can be quite far out. So here's a plus 17.4. That's plus 18.3. No problem. A plus 15 volts. Yeah, 14.8. That's okay. We've got a 5 volt up here. I think this is a logic. It's 5 volt. Yep, that's fine. And another 5 volt across here possibly. Yeah, it might be the same one. So far everything's looking okay on the power supply side. So I think I'm going to have to rip it apart. Let's get the circuit board out, and I think that means totally disassembling the whole thing, transformer, everything. Well, there's it scattered onto the workbench, and I did actually follow my original video on how it was all laid out on the workbench, because it keeps everything plugged in, including the large transformer, everything apart from one small header here, which goes away off to here. And luckily I'd kept the original little flying lead that I'd made in order that I could connect it up to the board there. So I'll just connect that now, and then we'll put on power. Yep, and I think we're ready for power up. And I've got the display just here. I should be able to see the VFD, and let's verify that error once again. So let me put power on now. So connect it up. Here, turn on the power and flick the switch. And I've got, and there the display is upside down to you, but I've got output off on it now, and I'll just turn output on, and I'm getting an error straight away. Now one thing I will have to do, I need to link out the sense terminals on the front of the unit, so I'll go way off and do that now. Okay, so I've been playing around with the circuit here on the workbench, and I've noticed one thing, and that is when I first switch on the power supply when it's cold, I get that error straight away, but it can vary how often that error comes up as I try to use the power supply. And in fact, the error can totally go away just by using the power supply. And I'm not sure, but I think that's possibly due, it's just the board heating up and the error going away. That said, I have been measuring the D to A converter and a few other points around the circuit board, and they're doing exactly what they're supposed to be doing. As you can see, when I was running the power supply, I am getting a good output. Error is just as an aside almost. I am getting a good output on both the ranges, the 8 volt and the 20 volt. The overvolt protection, overcurrent, everything seems to be working just fine. So I did a little bit of digging. I had a look in the service manual, and there's very, very little in the service manual regarding this error, but it does say error 718, gain out of range for gain error correction. And that's it. There's nothing else about what exactly that is. So I had a look at the schematic diagrams, and I think I may have found something. So here is the schematic for the D to A converter, and up in the top left there is the actual D to A converter IC itself. Single channel, however it's a multiplexed D to A converter. You can see the single output coming away down here and away off into the input of this demultiplexer IC, and there are the various analog outputs going away up into each of the op amps. And you've got a shift register IC driven by clock and data from the CPU, and that's providing the control signals for the demultiplexer in order to switch the various outputs on. And if you look up here, the very top op amp is the CV ref. That's the control voltage reference. This will be the signal that the user has demanded on the front panel, i.e. the output required. And that'll go way off to the analog electronics that drives the output of the power supply. And a couple other ones here. You've got OVP ref, over voltage protection reference, and CC ref, constant current reference. They'll go way off to the same part of the circuit. However, you've got an extra one in here, and that's tied in, if you look a little bit closer, to this top one here. the control voltage reference. You've got a non-inverting op-amp here, classic design. You've got a little filter on the input. There's your two resistors, R1 and R2, but instead of this resistor here being tied down to ground, it's actually tied to the output of the second op-amp. And you can see it's got its own gain control resistors there, and it actually outputs a way off to this bit underscored correction signal. So since it's tied into this bottom side of this resistor here, what that means is the gain of this op-amp's not going to change, but its offset on the output will, depending on what voltage this op-amp presents at the bottom of that resistor there. So this op-amp here can influence the output of the CV ref signal, and I think they're calling that the bit correction signal for whatever reason. So where does this bit correction signal go? Well, let's look at the A to D converter part of the schematic diagrams. And here is the A to D converter. Well, part of it anyway, at least the input side. You can see that you've got 4 analog inputs coming in here into this multiplexer IC, which goes all the way up to another part of the circuit which does the actual A to D conversion. But the 4 inputs are presented to the input of this multiplexer IC, and you've got I monitor 1, V monitor, I monitor 2, and those will be feedback signals from the output circuitry, and those signals will be providing the display on the actual power supply when it's reading the output terminals. And if you look closer, one of them is bit correction, BIT underscore CORR. So it looks like the signal from the D to A converter is being fed straight back into the A to D. And what I think that is doing, this is measuring some sort of gain or offset adjustment that the output from the D to A converter is handling. And I think that might be linked to the error that we're getting on the front panel. So what I want to do first off is actually scope the output from the D to A converter and also scope the input here, and let's see if we're getting any kind of erroneous values on those 4 signals there, especially the bit correction and after the multiplexer IC. Well, I've done some testing and measuring off camera there, and I think I've found something. So let me just jump back to the schematic and show you what I've found. So I did take a look at that bit correction signal and all the other signals coming into this multiplexer IC, and it all seemed to be working okay. I can't pretend to know exactly how the bit correction signal works, so I kind of just left that for the moment, and I started taking a look up here at the actual A to D converter circuit. And the way this works, it's actually a multi-slope converter. It's not like there's a dedicated A to D converter, because back in the day this was the best way to do it to get the resolution required. And basically you've got an integrator here which is continually charging and discharging these 2 capacitors here. And there is actually an analog switch at this side here which is switching some signals through as part of that process. Now if you look back down here, you've got the voltage reference circuit which generates a positive 10 volt and a minus 10 volt signal here, and they both go away up to that analog switch, and you can see the minus 10 volt goes away along here, up here, it goes through a resistor there and into that analog switch. And the one we want to look at in particular is the second one down. You've got pin 15, pin 2 and pin 1 there of that analog switch, and that's actually effectively a changeover switch, and I've drawn it out here a little bit clearer. You can see it's effectively an SPDT, single pole double throw, and one of the switches is always open whilst the other's always closed depending on the logic applied. And you can see pin 15 here is the common input output, and then you've got the individual switches pin 1 and pin 2 there, and this analog switch is actually bi-directional, can work in both directions. And pin 10, as I said, is the logic to switch it over. A low on pin 10 enables the switch here, the top switch, and a high on pin 10 enables the other one, this pin 1 here. And there is actually an enable on that analog switch, pin 6, but it's tied permanently low, which is handy because it means that this is active all of the time. So I've got power on right now. You'll hear beeping in the background. That's the actual error just resurfacing every few seconds there. Now if I go on to the minus 10 volt coming into that resistor that I mentioned, there it is there, and you can see it on the scope there, a nice minus 10 volt. The other side of that resistor, which goes directly to pin 15 over here, is permanently at 0 volts. No matter what mode I put the power supply into, no matter what I do with the rotary encoder, turning the voltage up and down, it's just permanently at 0 volts. And if you look here, there's pin 15, and you've got pins 1 and 2 at the other side, and you can see that pin 1 is actually tied down to ground. It's pin 2 that goes away off into the circuit over here, and it actually loops back as well onto pin 12 of one of the other switches. So there is pin 15 there, there's that resistor, so I'm getting a nice minus 10 volt at that side, but I'm getting 0 volts permanently on the other side. Now the resistor is okay, it measures about 28k in circuit, it's supposed to be a 30k resistor, so I'm assuming it's okay. So something, I think, is pulling down pin 15 down to 0 volts. And if you look at the other side, there's your pin 1 and pin 2, and you can see that pin 1 is tied to 0 volts. Pin 2 goes away off to the input of this op amp here, and also your positive 10 volt comes up into one of the other switches and out on pin 12. So basically the logic here looks like it's either selecting positive 10 volts or negative 10 volts on this line here. Now it could be that that switch is just never ever changed over, so let's take a look on the scope on the enable pin for that switch, which is pin 10, which comes away from the software. Let's take a look at that and see what it's doing. Okay, so let's take a look at pin 10, the logic, and you can see on the scope it's pulsing up and down between 0 and 5 volts. That's a good logic signal coming from the software. So therefore the analog switch should be changing over. So I can see no reason why the minus 10 volt is not going through the analog switch to the other side, unless one of the switches or one of the outputs on that analog switch is permanently shorted to ground. But let's take a look at the other analog switch on the positive 10 volt side. Well, there's the common input output on the scope there, and it is same story, permanently at 0 volts. And on the other side of the analog switch, and the other's at 0 volts as well. The positive 10 volts has got a problem as well. There's the enable, and it's pulsing away rather nicely as well. But I think the first thing I'm going to do is I'm going to scope both of the control lines for the two switches and just make sure they're not switching in sync with each other, because if they are, it would turn both of them on at the same time and cause a problem. So they should be inverted there. Okay, so let me go on to pins 10 and 11, the two enable lines for the switches, and you can see they are indeed inverted. There is some other pulses going on there, but looks like yep, there should only ever be minus 10 volts or positive 10 volts going through onto the commoned up side of those two switches. So there is that analog switch U32. I'm just going to change it out. I think I've done enough scoping on this chip without getting too deep. So let's change it out and see if that makes any difference. So there it is. I did it off camera because my hand was in the way. So let's clean up the pads and fit the new one. Right, ready for a power up. Power on, and the way to start it beeping if there's still a problem is I just recall the previous output voltages. No, still got an error. So that wasn't the problem. What else could it be? Well, I think I actually made a bit of an error on the functionality here. And I actually think the 4053 analog switch is working okay. If I go in scope pin 6 of this op amp here, the output, we can see some evidence of that. So there is the output of the op amp. I've actually scaled it up so it's 500 millivolts per division, and you can see here is the current steering working. It's switching between a minus 10 volt and a positive 10 volt supply for that current steering through the analog switch, and you can see that the rate this is happening at is exactly the same as the enable pins on both of those analog switches. So this is actually working perfectly. Well, this is all getting rather curious now. I was setting up the front panel here to give it a maximum current on CC mode of 5 amps above what I was setting the electronic load to, and the error disappeared. As you can see, no error, and everything is functioning just perfect. That is the output voltage I'm getting off camera, and I'll just check the current. I've got it set to 3 amp on the electronic load, so I'll just turn that on. And yep, you can see that's 3 amps, perfect. Turn it back off again. And if I set the, well, I'd set it to 6 amps there. So if I set it to 1 amp, it should go into CC, or 2 amps, it should go into CC mode. Yep. Just turn it on. And yep. 2 amps, and it drops the voltage down. So it's working now. So what did I do? Well, let me put power off. Power back on again. And turn on the output. Well, I'll just recall the existing. And we're getting an error again. Now I'll change output current back up to 6 amps if I can. Look at that, 8.5 amps, and then it clears. So let me just clear the error. Do it again. Doesn't look like we're getting the error now. If I go back down to 2 amps, I wonder if the analog side of the circuitry on the board's working fine. We've actually got some sort of data corruption that causes a problem. Or we could still have an issue on the current side, but as I just demonstrated, it's working fine. It's going into CC mode perfectly, and it's recording the right current on the display. It's not like it's jumped out of calibration. Maybe we've got a bad E² prom and a bad RAM IC. It definitely could be the RAM IC, because I've had these faulty on these power supplies before. Not this particular one from my original repair, but certainly the other one on the workbench had a bad RAM. Okay, that's the RAM IC fitted. A bit of a job because this row of pins here are about 2 millimeters away from the side of this socket, but I managed it. So let's just reposition the camera and power up and see what happens. Here we go. And I'll just try turning the output on. No, still got the error. Wow. Well, nothing to lose. I think I'll just change out this E² prom. It's really easy to access because that's it right there. Okay, that's the new EEPROM fitted and programmed with the data from the one I removed. So let's just zoom out and reposition the camera here. And let's try a power up. Right, output on. No, still got the problem. Wow. Still got that erroneous funny reading there and the voltage as well. Really weird. They don't reflect output. I just wonder whether the whole thing now needs a recalibration, given that I've changed out the RAM and the E² prom. There's still some corruption in the E² prom, maybe. Calibration data. And a recalibration might fix it, although it does work when I clear the error. Right, I've just gone through the calibration procedure. Managed to hook it up to my electronic load and run through the voltage calibration and the current calibration all the way up to 20 amps, and it all successfully completed, and I've now switched off power as per the instructions, and we're going to power up and see if that makes any difference. So let me just zoom in on the display here, and you'll probably hear it before you see it if there's still got a problem. Here we go. Oh, turn on output. No beeping! No beeping! Wow! Right. Let's just set the display limit. Wow, it's a lot more accurate now that it's been recalibrated. Well, slightly more accurate anyway. Oh. Right, I'll turn on my electronic load. I've got it set for I'll just set it up for 2 amps. And yep, it's drawing 2 amps. Perfect. Wow. Looks like it's fixed. So if I just change that down to 1. Yep, it's going into CC mode. Constant current mode. Perfect. So what was wrong with it? Well, one of two things. Either the calibration just drifted slightly and the unit knew about that when it powered up, but pushed me down the wrong road with that error message, or we did have an E² prom problem, slight corruption maybe, and despite fitting the new one, because I'd read the data out of the old one, I was back to square one, so it needed the new new EEPROM and a full recalibration. Who knows? But it's one of my most favourite power supplies in the workshop to use. I use it all the time. It's at the far end of the workbench. It's not my daily driver, but it's the one I go to when I want to charge stuff, or charge PDVS2 minis or anything like that. It's dead easy to use, and I get quite high currents out of it. 0 to 8 volts 20 amps, 0 to 20 amps at 20 volts 10 amps. So really versatile in that respect for a single channel power supply. So it looks like it's working okay, so I'll just put power off And power up again, just to make sure, but this time I'll try recalling one of the saved setups. Yes! Perfect. So I'll go away now and put it back together. Well, there it is, all back together again. And yes, probably a simple enough repair if I knew from the start, but I was put well off the scent by a very specific error code which pointed me off in completely the wrong direction, really. Whether the E² prom was faulty or not, who knows, or was it just calibration drift? I don't know. I do know that some of the resistors on the board, I've had problems with them before in other Agilent power supplies where they drift, and yes, was one power supply where I ended up changing out all of them, but I don't think we're quite ready for this yet. On this power supply, I think I'll run it for a while and see how it goes. So thanks for watching, and remember, you can always comment down below what do you think was the problem with the power supply, and don't forget to like and subscribe. It really does help the channel grow. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.